Hello everyone, and welcome to this example recording on your source-free RC circuit. So the question we'll be looking at reads as follows. For the circuit below, determine V0 for t greater than 0. V0 would be the voltage that is associated with your capacitor. And the question then also continues to say determine the current Ix. So we need to find a way to determine that current Ix from the voltage response of the capacitor that we're looking at. Alright, so let's start off by defining the response. So effectively what's happening in the circuit is that at time t is equals to 0, the circuit is opening, hence why we would term it a source-free response. So the circuit opens at time t is equals to 0. Right, so given that we know that it's a source-free response, we know that Vt is going to give us V0 e to the negative t over tau. So we need to get V0 and we need to get the time constant tau. When t is equals to 0 negative, just before the change, what happens? We can take a look at the complete circuit. We know that the capacitor becomes an open circuit, and then we're going to have the resistor 5 and 20. We're looking for the voltage V0. So we can put these two resistors that are in parallel because they share two common nodes. We can put them together in parallel. Right, and that will give us a value of 20 ohms in parallel with 5 ohms, and this should give you 4 ohms. So that will be 4. Right, now we can see that we're looking for V0, and V0 should match the voltage across the 4 ohm resistor. So we can use voltage division, and we can say that VO is equals to 4 over 4 plus 10 multiplied by 15. Right, so that's 4 over 4 plus 10 multiplied by 15 volt source, and that gives us a value of 4.28 volts. Right, so the initial voltage is equals to 4.28 volts. Now what happens when t is greater than 0? When t is greater than 0, this whole part of the circuit falls away, and what we have left is the capacitor. We have the 5 ohm resistor, we've got the 20 ohm resistor, and we will be looking for R equivalent, looking into those terminals, and C equivalent, which we should be able to see is 10 farads, given that the response is over one capacitor. So R equivalent, which is equals to RTH, must give us 20 in parallel with 5, which gives you 4 ohms. C equivalent is equals to 10 farads. Therefore tau is equals to RC, which is going to give you 4 times 10, which gives you 40 seconds. And then finally we can say the voltage Vt is going to give you V0 e to the negative t over tau, which gives you 4,28 e to the negative t over tau, which is 40. and that will all be given in volts, right? And this is the output that we're looking at over the capacitor. Now we are required to also look for the current Ix. So how will we find the current Ix? How can we link the current Ix to the output that we've just found? We should be able to see that the voltage drop from there to there should be the same as the voltage drop from there to there, which in fact is the same as the voltage drop from there to there. So the voltage drop here should be the V0 that we've calculated. So for us to determine this current, we can then just say it's equal to the voltage expression we've calculated divided by the resistance, which is all. So Ix is going to give us 4,28 e to the negative t over 40 divided by the 5 ohms. And that's going to give us a final value of 0,85. So that gives us 0,85 e to the negative t over 40, and this will now be amps. That's Ix as a function of time. Thank you for watching this video and enjoy the course.